practicals, we'll be using one of our platform called AINexus. So that will be used by any one of you if you want to practice whatever we're doing in the session. You could do it on our AINexus platform itself. That way, you could follow along the development process. And we also provided you with tools to ask questions. So you could also, everyone can use the AINexus platform. Shivani or Srijan, someone can, if you can share the platform, our AINexus URL, and have others sign in. We will go through this initial slides and then get on to practicals. The agenda for today is we are only going over few frameworks, which are no code, low code, and no code solutions, which are out there to build AI agents. Even if you are coming from a non-technical background, you can also follow along with this course. Since we provided no code solutions as well to build the exact same travel agent, you could use tools to build your own no code solution as well. And for others who are developers and who have experience with development, we do have code solutions as well. And we will also go through different parts of the frameworks, mainly some basics about frameworks. It is pretty high. We're not going too in depth. We're not discussing advanced memory management. We're not going in depth. This agent doesn't have a lot of tools. It's basic agent with simple tools. We have follow-up sessions where we'll be covering more advanced concepts like memory, but this session is pretty limited to creating some simple tools. Before I get started, I could have gone over individually asking about your background, but there are quite a few. So it would be great if everyone can drop your introductions in the chat so that everyone knows about your background. If you can drop in your name, your position, and any experience in building or working on Gen AI, or are you a developer or not? So some things like maybe these will be some basic information that you can share so that others can connect with you. And the end goal of these sessions is to create a community where we learn and thrive, and also follow or learn from everyone's experience. So that's the major goal of these presentation. And coming to the questions, you could drop your questions anytime in the chat. I will give some time during the presentation. We would probably take a couple of questions, not more than that. And then we will move forward with other presentation. We don't want to have the discussion really lengthy. So if in case you want to have more detailed discussion, you can always reach back to us through LinkedIn. So let's get started. So if you are already aware of large language models, I just want to give a brief introduction. I don't want to miss time on this. So what is a large language model? So if you are all aware of ChatGPT, so ChatGPT is a product from OpenAI, but that itself is powered by a model called like GPT series models. It could be GPT-3, GPT 3.5 or GPT-4 or GPT-4o, 4o mini. These are the recent models that are coming out from OpenAI. And it could also be other models which are open source from Llama. So all of these are large language models. So what makes a large language model? So in 2017, Transformers is the basic architecture that is really, it really helps it's very scalable, and it is also something that is generalizing across different domains. So you could have voice or vision. So transformers are the basic building blocks of these GPTs or these large language models. And the applications of these large language models are, you could do content generation, the chatbots, code generation, and data analysis are some of the basic tasks that this large language model could do. And could also handle different complex tasks. Reasoning is one of the important abilities that these large language models possess, because these large language models are trained from data across internet, and they are also they use a lot of computation to get trained. So they're trained on trillions of tokens. A token could be a word or more than a word or less than a word in our vocabulary. So these models are trained with a lot of data from the internet and with huge compute across GPUs for months and months, and that is how a large language model is created. You know, maybe a small or medium or even large enterprises does not need to create a large language model, because these models could be a commodity that everyone could consume and probably build their own small language models with it, or use their large language model as it is, consume that through an API. You have closed source and open source model outside that you can make use of. The challenge with large language model is the knowledge cutoff, because ChatGPT is not trained continuously. It has only knowledge about all the events that happened until April 2024. After that, they are not aware of any of the knowledge after that. If any new inventions that happen, ChatGPT would not be aware of it unless you provide it with browser access. I think some of the platforms now, they're offering that. Even ChatGPT offers that option to navigate the web to get the data, but LLM would not inherently know that. So that is called a knowledge cutoff problem. Since these are resource intensive, these models are not continuously trained. And as I said, there's different examples, like GPT-4, PaLM series models, or Llama models from Meta. And there is one more challenge is the data, since it is from the internet, the data could have a lot of sensitive information, and it could also have data that is biased towards a specific culture or a region or a gender. So that is a challenge with large language models. Why are we using AI agents? So if in case you already used LLMs, maybe programmatically, you're trying to call these LLMs to get answers to your questions, or you're just using ChatGPT, that should be good enough for you on day-to-day task. But if in case you're going ahead with building a system that is autonomous and that can basically do multi-step reasoning to accomplish a task, like some tasks could be booking flights, planning out travel, or it could also be a co-pilot for an attorney, or a co-pilot for a lawyer, co-pilot for a doctor, co-pilot for a developer, who are, agent that is working with different tools, which also remembers or which also personalizes your information. That would be treated as an agent when compared with an LLM. So LLMs inherently have constraints. LLMs could hallucinate. So agents would help us to create multi-step processes. We're doing all this programmatically. So if you're a developer, what we're doing here is calling an LLM through an API, and then
start software engineering, I'm learning AI and full stack development.
sorry. Yeah. So basically we will be using these AI agents that we will be creating a framework. So there are a lot of frameworks outside that help us to create AI agents that will have access to tools, that will have access to memory, have access to an environment to go out and work on a specific task. Even though tools like ChatGPT can do reasoning, the thing that differs from ChatGPT and an AI agent is AI agent could be working in your own environment with your own tool set to accomplish a specific task. ChatGPT could do your planning, but it might not go ahead and book a flight. It can create an email, but it cannot go ahead and send that email to your customers. It could create a email, but you again have to ask it different questions around if the email is, it has empathy, if the email has any sensitive data. This validation is something that you could do, but you have to manually do a lot of back and forth through a chat interface. if in case you're just using an LLM like ChatGPT or something like that. So AI agents are more of simply they are basically doing multiple calls to an LLM, but you're also creating a framework which will improve the output, the quality of the output, the quality of generation. If you're trying to use an agent or an LLM to get a output, maybe it could be an email, it could also be some content for your blog, it could also be analysis of a complicated case that you're dealing with. A multi-step process, multi-step framework or multi-agent frameworks would give you a better output when compared with a simple call to an LLM. So that is where these agents are really important. So it's autonomy, integrations, scalability, all of these are enabled through an AI agent. So that's the reason why AI agents will boost your productivity tremendously. And the future, that is 2025, is the year of AI agents. So you would see a lot of AI agents working alongside with us and accomplishing specific tasks. They could be a little bit of autonomy already there for these AI agents, but still AI agents are not reliable unless you build it in a very efficient fashion. They still are undeterministic. If you write your application code never changes the behavior, but AI agents could have different behaviors. So you should always have human in the loop. You should always have a human as a manager for these AI agents. So AI agents cannot completely replace a human. AI agents can definitely boost the productivity of any individual, but they cannot replace a human, at least for now, because of the inherent problems that they have. So what are the different components of an AI agent? So AI agent could have a lot of different components here. It does planning. It is inherently coming from the LLM itself, which does planning. It does have tools that can help it to accomplish a specific task, to accomplish or to take some actions. It also has memory to store all of the previous actions. It could be a short-term memory that is used to store the temporary information while working on a specific task, or it could be a long-term memory that is needed throughout different sessions and throughout different interactions. Example, maybe you have your personal agent that remembers your personal details, your age, or maybe your preferences, maybe you're vegetarian, or when you're traveling, whether you are comfortable going in in a specific time. So these are some personal preferences that could be stored in a long-term memory that can basically change the way the way agent behaves. So that's more hyper personalized AI agents that can store this information, store these memories in long-term memory. As far as agent, there are different ways in which the planning happens. So they could be self-reflection, chain of thought, sub-goal decomposition, self-critic. So all of these are basically how are you planning a specific task. If you're trying for a trip from Hyderabad to Bengaluru, how are you going to plan it? What time are you leaving? How are you going to break it down? How many days the trip is for? And in order to do the planning, first thing you have to take care of the flights, and then comes your accommodation, then comes your local destinations that you can plan. So the whole travel plan could be divided into various subtasks, and then your LLM does that planning accordingly. So these different planning strategies are just dividing a huge goal into simple tasks, and then and working on individual tasks. That way, AI agent can accomplish really huge, complicated tasks, just like how we break it down into smaller chunks and work on it. Their agentic patterns are really important in the sense that most of the agents, they follow specific patterns to to give you the best response output. We humans, we review multiple times when we write, and we check for mistakes, and we again refine that a bit. So that is what reflection is. Just like how after we write an essay, we go ahead and read it or proofread it and again change or update some part of it. The same thing happens with these agents. And we call it a reflection pattern, where it's just reflecting on its previous progress and then refining it or making it better. React pattern is reasoning and acting. So just like how we reason and take action using specific tools, AI agents, it's one of a very famous pattern that are mostly adopted by any agent. It's a simpler pattern. It's reasoning and acting. So it goes ahead, reasons what it has to do, and then it takes action, and it observes that and go back and reiterates through that same process. So if you want to book a flight, we need a browser to access internet, and then browser could be a tool that it has to go ahead and research for this. So it has to realize that it needs a tool and then goes and acts using that tool. So that is what React pattern is. I think we can pretty much relate to these patterns because that is how we as humans work. And these are pretty familiar with most of us. Prompt engineering is very important for agent because prompts really play a key role in crafting the agent personality. If you want to create a multi-agent system, you would need to create different agents for different purpose. So if you have a travel agent, then you could divide the travel agent into different subtasks. Maybe a research agent who only does research, and maybe a planner agent who only does planner. So in order to craft the personality of the agent, prompt engineering is really important. You could give instructions on how to use different tools. You could customize any specific interactions. You can also maintain your quality of response to proper prompt engineering. So it's always important. There is also, prompt engineering is a broader term, but it's domain specific too. If you're trying to build an AI agent for travel domain, it's always recommended to have a domain expert who can properly give the guidance. If you're building it for a financial agent, maybe someone already knows some knowledge about finance would really add a lot more value to this prompt engineering. Just knowing prompt engineering, I mean, there are a lot of individuals who think, okay, prompt engineering, if you know that, then you could just conquer Gen AI, but that's not right. It's prompt engineering with your domain knowledge that will add more value to any agents that you're building. So yeah, I think this is the basics of AI agents, and then we'll go through different frameworks in AI agents. We'll go through LangGraph and all, but before that, I would like to share the other screen where I'll be showing you the platform and how you can follow along that platform. Basically go through different, go through the code that is already there. Let me share my screen. Okay. So what we're trying to do is so this is the travel agent. I think if you all have access to this platform, please go ahead and sign in to this platform. I don't know if anyone has shared this link. I don't think no one. Okay, yeah.
I already have shared it.
Yes. So you all can sign up and start using this. So this is the first tutorial. It's a travel agent, and you would see there are 3 different solutions. One is the no-code solution. And you have a low-code solution. And then comes the actual code solution, which is using LangGraph. Low code is Crew AI framework. We'll be using Crew AI. We call it low code because of a little bit of, it's not that complicated as LangGraph. It has a lot of code that we probably need to work on the LangGraph side. But yeah, this is the no code solution. It is through a tool called NA10. So you could use this link to register NA10 if in case you're not technical and you want to create a travel agent. You can follow along this video, and you can also click here and explore different settings of this NA10. So it should be straightforward. We will go through the low code and the code solution. I'll just go through a basics about this. I mean, what are the basic fundamentals of this framework and execute it. And this is a code solution that is using LangGraph. And in any of these sessions, if you have a question, maybe it could be a basic question or anything related to your to this tutorial, always please take help here. You can ask any question related to this tutorial and you'll get a response from here. It could be code questions. It could also be any questions related to AI agents. You can ask it here, and it will help you out with your, with your task implementing it. I would recommend all of you follow along and start executing these cells. And then, you could also, you also have a UI that will load up end of this tutorial where you can actually see this AI agent that is built. So I don't know how many of you are already aware of Crew AI, but so Crew AI is a framework. It's an open source framework that's been used as of now by a lot of companies. Like a lot of almost 40 to 50% of the Fortune 500 companies are using Crew AI. It's a low code solution because it's very easy to build multi-agentic systems, and they call it a crew because a crew could have different group of agents working to accomplish a specific task. And they do, you would also see there are a lot of crews already built using Crew AI now in production. They say they are using in production as of now. It's Python based, and if you see, a AI crew could be combination of different agents. So let's say you would have an expert writer agent and an expert researcher or an expert engineer. So they all work or delegate work to each other to accomplish a specific task. So if you see overview, if it can ask to create this app, and you would have a writer who writes the documentation for the app, and then an expert researcher who researches about that app, and then engineer who would write the code for that app. And probably together they can build an app for you by creating crew. And we are just, since all of these agents are just like humans, they have using LLMs cognition and also using different tools to take action, just like how we do, by emulating different organizations or a manager and subordinates structure where you have a manager who reviews work of others agents who are individually working on it, or maybe a manager reviewing work from his team members. Similarly, we're creating a crew like this, and we're just emulating the same pattern here by creating a hierarchical pattern. Or there are different patterns too, but we're not going too deep into that patterns. But as of now, it's just a generic overview of how it works. So in Crew AI, you create a crew. In our case, it will be a travel AI agent crew. And there would be individual agents that will be working as part of that crew. In our case, you will have a researcher agent, you'll have a planner agent, and each agent would have a set of tools to accomplish a specific task. And you also define a process. So process will basically define how agents have to work together, how tasks can be assigned, and how they will perform the task, all of them together perform a specific task. And task can they can override in agent tools as well. So they can, that each individual task could be independent, and they all work together to achieve a specific goal. In our case, it is a travel AI agent, so we might have to travel a specific. If you want to travel somewhere, you basically you ask for a plan. You provide them with source and destination, and it will plan your travel. That is what the AI agent should be doing. So this is the workflow. You have a user query, and you have your LLM will understand that query, and then it will research flights, hotels, and destinations and plan the itinerary. So this is the overall high-level overview of this travel AI agent. We'll go back and see how we can implement this on our platform. So I'll go over a little bit of code as well. And if you are, it's on Jupyter Notebook, so I think it's easy to follow along. So if you see here, basically what we're using is the research flights for finding different flights and creating comprehensive travel itinerary. So these are the 3 different agents that we'll be using here. And we'll be using Crew AI as we discussed, and we're using agent, crew, process, and task. These are the 4 abstraction module libraries that Crew AI provides in order to build an AI agent. So we can go ahead and execute this. And here you have this agent, tools, models, and tasks. We can configure all of them here. Here, what we're trying to do is we'll be using class, the flight info, flight search, and hotel search. These are the inputs to we are basically creating a data model on how this information would be passed to the agent to get us details about a specific travel planning. So it could be hotel search. So, where we are looking for the hotel, check-in and check-out dates. Flight search, we want to know exactly departure or arrival information, outbound date. So we are basically creating this because LLMs are good at understanding structured input and also generating a structured output. So if you see here, these specific class will defines all this base model, and we're using Pydantic here. So Pydantic is really good at defining all these models, and Pydantic also has their own agentic framework, which probably we'll be doing later on. But as of now, this is for Crew AI, and these are 3 different classes that will be used that are defined for the LLM to give a specific output in a specific format. So it's called structured output. These LLMs are really good at providing you the output in a certain way. So and if you use, and here what we're trying to do is we are going ahead and using Google search from SERP API. So in order to look for flights, in order to look for hotels, you would need Google search. And we are using SERP API Google search library to go ahead and get the flight information and also hotel information. And if you see here, we are also using this base tool because we are defining our tools here. Previously, we have defined our data models of different inputs to the model and how we are expecting the output from a model, LLM, or from our agent. And if you see here, the flight search tool, it takes in the flight search information as an argument, and it also takes other arguments, and it basically takes in all the parameters, including departure, arrival, outbound date, currency, and it uses Google search to search for flights using those criteria and generates results in a specific format. And what we're trying to do here is we are basically formatting this information into a readable string. So I think it's pretty straightforward. You can always, if in case you want to understand a specific part of this implementation, always just go ahead, copy this part, and you can always ask our travel AI assistant to explain this part, explain if in case you need more information regarding this. And hotel search tool is the exact same thing. You can use this hotel search tool in a similar way. But this part is actually searching for hotels. So this is a tool for searching the hotels, and we are again using Google search. And here we are formatting that output. And these are very important configurations because agent configuration will define how what kind of agents we are using. So there are 3 agents. One is the flight researcher, hotel researcher, and travel planner. So these are the three agents that we are using within our crew. So flight researcher will actually research on different flights. Hotel will different research on hotels, and travel planner will basically plan or create the travel itineraries and everything. So these are three different agents. And we also define task for this agent. So in order to research flights, how do you research flights? So here you define all of the steps that are needed to research the flights. And you also pass in the timestamp, the current timestamp here, because when you're going ahead and booking the flight, you ask it, okay, I want to, can you go ahead and book a flight from, Bengaluru to Hyderabad next week. So it would probably use timestamp to learn about the exact date now, and then take its decision on what would be the dates for the next week. So that is one of the tasks or this is a few of the things that a research flight a task that a research flight would be used by the flight researcher agent. And this is research hotel, and this is create itineraries. These are different tasks that are used by these specific agents. And then we are implementing this crew. How we are implementing the crew, as we know, it's made up of all of the, it's made up of all these three agents. So what you're trying to do is, firstly, you're initializing the crew with all the necessary tools. So we know we created two tools here. One is the flight search tool, and then the hotel search tool. And we are also defining this function for the flight researcher. And we are taking the agent configs from this. So if in case you want to change the prompt or you want to change the persona of this agent, all you have to do is come here and change you can change the flight researcher persona or flight researcher behavior from here, like what it has to do, what is the what is the major goal of this flight researcher, and also add or refine more steps here. So that is the reason we call it a low code solution, because you're not going ahead and changing all of the code. You're only changing these configurations, and rest of the code is basically boilerplate code, which is really common for any of the implementations. And flight researcher is the hotel researcher, and here you have the travel planner. And again, you define all of the task as well. This is a research flights task, and the agent that will be using this task is the flight researcher. And here you have the research hotel task, and the agent that will be using, this task is the hotel researcher agent. And this is the create itinerary task, which is the travel planner that will be using this specific task. And now you're just going ahead and getting this crew. So you're basically creating this crew. And then, you're just asking it to plan a trip by giving it a small input. And then here we can test out the travel planner. Then, yeah, I think there's some small issue with this Gradio. I think it's, so usually you get a UI link that can be used, to showcase the UI for this travel planner. But yeah, I think we can go through this code in the line graph. I think there we can actually see that UI, that entire implementation on the UI. I think there was some issue with this even in the morning in the other meetup.
Raj, I think in the low code scenario, you need to restart the kernel and then it works.
Okay.
Yeah.
Take some time to load actually the gradient.
Okay, should I?
Yeah, click on kernel and then restart the kernel.
Yeah, restart kernel.
Okay.
Yeah,
Thank you,
now,
Hemant.
yeah.
Okay. So let's go ahead and hopefully it restarted. Yeah. Just a minute. Yeah. So let me go ahead and run all the cells and see. Even in the morning, I had some issue with this, Imank. I think there's some.
I had to run in the code one, not the low code. Maybe it works there. I don't done there.
Okay, that's fine. We can look into the code one. Raj, let's not look into
Yes. Can you look into that? Yeah. I think there's some small, even in the morning, I had the same issue. But yeah, no problem. We can see the UI on the LangGraph side. So as we previously seen, so Crew AI, there was, we'll go through the LangGraph and we'll also see a UI here where you can actually ask questions and everything. So LangGraph framework is actually from LangChain. So it can be used to create stateful and multi-agent applications, similarly how we have done for Crew AI. And since it's from LangChain, there's a lot of it's a huge community, open source community. It came up. LangGraph is definitely used in production. Crew AI can also be used in production. But Crew AI is slowly rolling out features that will really be useful in production, like features like flows, Crew AI flows, which we haven't implemented that here yet, since we want to cover multiple frameworks. So LangGraph also provide some, all of this execution in terms of a graph. If any one of you are data engineers here, if you're aware of DAGs, which are, acyclic, directed acyclic graphs, these are more of a cyclic graphs that you can create with LangGraph. And you would also implement something like human in the loop, where you can create a node that can, basically take input from humans and then go ahead and proceed with the next execution. You could also have human in the loop implementation Crew AI, but at the moment we don't have that implementation yet. As of now, it's more of chatbot interface that we have for this basic travel AI agent. You can use Python and JavaScript for LangGraph. And the structure, it does have, structured as a node. There could be conditional edges. There could be other nodes. So each node could be an AI agent. Just like our own Crew AI, you have multi-agents that are created by a crew, and you have different agents and tasks. That vocabulary is really straightforward to understand. But LangGraph is a bit more technical because you are thinking of this cognitive architecture in terms of a graph. So you have a node. You also have different edges on how that specific a node would be a agent LLM call, and then the conditional edge will probably make a decision on which path to take in the next step. When you go ahead and book a flight, then you have to go and book your hotels, and then you have to book your rental cars. So these could be different workflows. Maybe if the flights are not available, probably it has to go back, take a different approach. Or if you're just going from your destination from maybe Bengaluru to Mysore, maybe, or maybe a small outskirt from in Bengaluru. So you may not need to fly, you can probably drive. So it could be a different workflow, right? So you can create all of them through some conditional edges. So you can create more robust LangGraph agents through this. And what we're doing with LangGraph here is we're using React pattern. I think we already discussed this React pattern here. React pattern is basically reasoning and action. So it does a bit of reasoning on what action it has to take, how it has to reason through a specific task, and then use tools to take the action. So this is the basic React, and here there's a React with structured output, because we are using structured output. So that is the reason why you have a respond node here, which will be responding in a specific structured output. And that's what we're using now, this travel AI agent. So let's go ahead and see the code here. So travel AI agent, we will be using the similar approach. We are installing all of this libraries, and we have the system prompt. And if you see here, the LangGraph library, we're using create React agent, because React agent, the pattern is pre-built already. It's a very famous pattern that is used across different agents. And you have some of the modules that you're using here is system message, human message. So system message is how you're crafting your agent with You're telling your agent you're a travel agent or you're a researcher agent. So that is what a system message is. Human message is what we type in to get a response. And you're also using something called memory here, which is the checkpoint is a concept, is a checkpoint is a concept in LangGraph where you can actually save every state of your LangGraph execution. When your LangGraph is, when you're going to book a flight, every specific action or every data flow between different nodes could define one state, and you could always go back to any of your checkpoints. So that would also help in saving your memory. Your memory is actually built on these checkpoints, and how this overall state of the system changed, how your travel agent worked to perform a specific booking. If it failed, you could at least go back and audit and review how it, what were the series of steps that it took to accomplish something, or even if it fails, but how it failed. So that is a value that LangGraph adds, because it's very visible in terms of auditability. Observability is really detailed here with LangGraph, where you can backtrack and check for the behavior in production as well. You are defining your system prompts here. The system prompts will define how your research is done. So research prompt is says exactly how to do the research, and travel plan is give more information on how the plan has to look for. Is it like day-to-day itinerary, flights and accommodation, estimated costs and budgeting. And here we are implementing the search tool. We are using the exact similar code base here to implement these, the search tools and all. Yeah. So as we previously discussed, so it's using the same base model and others. So this is the search tool that we implemented, and then here we are loading all of the environment variables. We are loading the OpenAI key, and here we'll be using the travel. Will be implementing this travel plan and everything. We're passing all this information to the agent executor. So agent executor is a very important concept within LangGraph, where you're invoking or creating. You can use that to create an agent by passing the system message and the human message. And the system message is a research prompt, which actually tells how the research is happening here. And you have the other one, which is a creation of a personalized travel plan. That's again, this is again an implementation how you're invoking the model with system message and human message, and you have your prompt here, which is the travel plan prompt that we already defined over here. So and once this is done, now you have this usage. And we are using Gradio to just expose this. Later on, we have other plans to give you better access to this UI, but now this Gradio. So yeah, we have implemented our travel AI agent. So what we can do is we can plan a 4-day trip from Rabat. So I'll just do this. Let's see how it works. Okay, maybe some issue. Let me save this. Let me see what is the error here. Okay. Okay, there's some issue here. Connection error doubt. Just get travel plan is not defined. Actually, I had, oh, maybe this is not executed here. Okay. Let's re-execute this. Yeah, I think I missed one of the cells. Let me just get this here. I'm sorry, this is a new platform, so there's a lot of issues going on with this. New trip. Okay, it's working. So it's basically planning this trip out for us from, oh God, I don't know what's going on. Shiman, can you check what's going on here?
Yeah, looking.
Or we can move this kernel or restart it. Yeah, I think this this code actually works, but only thing is I think we have some, it's a new, we just introduced this. This is the first day we're actually using this. It's still in the beta phase, so we are encountering some issues here while executing it. But yeah, let's see if we can fix this or not, or maybe not. Let's see. And it is not properly implemented as of now because everyone are using the same instance. If you see, everyone has only read only for this. We can't execute, we can't change any of the cells. We are about to change that. As of now, we are not using Jupyter Hub. We are just using a single instance of Jupyter Jupyter Notebook. Probably will change that soon. Yeah.
That it's actually working. So just can you either you can use this Gradio link I just shared on the Zoom.
Okay. Sure. Thank you.
Yeah, use this Gradio link. It's actually, I think your one of the shell did not load. That's where.
Okay. Thank you.
Yeah.
So yeah, so it's going ahead and planning this 3-day trip from Hyderabad to Bengaluru. And we're using line graph here. So let's wait for this execution. Soon we are going to create our own, instead of Gradio, we'll be using our own in-house ingress or something like that in Kubernetes to expose this link. But yeah, there you go. So you can see, right? It's what it is doing is it's since I say for next week and it already has access to the current timestamp, it was able to find, basically do that 3-day trip. So considering today date is Jan 3rd, next week would fall around Jan 10 to 12th, and then here it's just going ahead and getting the flight details. But I see here there's an issue with this. I don't know if it is an API issue. It didn't return the flight information. And here just looking for, it provided us with all of these different accommodation. And here you are also, you have all this estimated costs information as well on, what would be the cost per night and all of it. You could even type in the budget information as well to plan it in a certain budget. And it was also talking about local transportation and day-by-day itineraries here on how you can plan this specific trip. Yeah, but I don't know why the flights is not working. Can someone check why? Is there any issue with the SERPI API in the backend? Srijan?
Just a minute.
Yes. So usually maybe if you're out of some credits, that's the reason why it was not able to get flights. But yeah, it was able to plan out all of the trip with accommodation, the estimated costs. Maybe I can say with budget around 10K. Awesome. Please, let's see if it is. Let's read it. Since we have given the budget information, it takes that budget into consideration. Yeah, I think there's some issue going on with the flights. That's the reason why it's not able to get the flight information. Usually we use SERPI API to get even the flights information. So let's see. I think someone is checking for that and will get back to us with this. But it did plan for all of this accommodation by taking into consideration the budget details, which I clearly see. If the flight information populated, then it would also get the cost of price of the flight, and it would probably plan it out with taking that into consideration. But since we only give 10,000, it doesn't have a lot of information here to even decide that. So there is some clear failure in this agent for detecting or to get the information of flights. So we might look into that. But yeah, this is the implementation that we have from LangGraph. And here you have a no-code solution. I think no-code solution is through NA10. It's straightforward. You can go ahead and register for NA10 here and start implementing this. It will have a lot of you can create different steps. You can create all of these different modules, different specific nodes, and then connect them together. So you see here, you have the AI agent module, and then you can connect that to the OpenAI chat model. You have memory. You also have SERP API that is used to search for different flights. And this could be used to build this AI agent, but it is no code, so it's just more of building blocks. But still, you might have to work on some basic integrations here. You can see all of the settings. You have the text. This is your system prompt that you'd be using, and then you will also have settings here that could be used to to add any specific settings needed. And you also have this Postgres chat memory, which will also store all of your previous chats and everything. So yes, I think that's I think Srijan, do you or someone is there or someone is here who can show us this implementation?
Somebody is here. He is going to present.
Yes,
Yes.
right.
Someone, can you go ahead and and present the NA10 implementation? And others, if you want to go ahead and work with this, you can. But I think we'll figure it out why this flight is not, details are not populating, and we'll get back to you probably shortly.
Raj,
Yeah.
First, we have reached the limit on the SERP API.
Oh, we did the reach the limit. Okay. Is it possible to create a new link, a new API key for the SERP API?
No, Raj. Currently, we need to stop the Jupyter. Then we need to load the keys again.
Oh, okay, okay, yeah, no problem. So it's the reason why we are not able to see this flight details is SERP API, the free version has a limit. So we already crossed that limit. So I don't know, maybe a lot of us are already using it, or maybe SERP
Yeah, I
API.
think already it's the 80 people, so mostly like
Yeah, I think that's expected. So there might be a lot of requests that went in, and that really exhausted the SERP API. We're not expecting 80, but yeah, we'll try to see if we can do that before this call ends, or maybe you can play around with this or use the same code and work on the implementation. But yeah, I think Samnini will show you the NA10 implementation and how you could do the NA10. If someone who doesn't know how to code, you can follow along this. It's pretty straightforward. Samnini, thank you. Go ahead.
Yeah. Yep. Hello everyone. So you can create your NA10 account using the link on the website. You can go ahead and click on that link and sign up for NA10. Once you finish set up the account, it's very simple and pretty straightforward. You can just click on add workflow, and let us add the first node, chart trigger. You can make this chart publicly available if you want. Just enable this. Now let us add an AI agent to this chart. And this agent, I'm selecting OpenAI functions agent. And we also have conversational agent and React agent. You can play around with it. And here you need to define your prompt for the agent. Let's say if you are using a travel agent, you need to define a prompt and how do you want your agent to behave. I'm using this prompt. Just add it here. Now let's add chat model to this agent. I'm using OpenAI chat model. And for this, you need OpenAI API key. So you can use the link on the website. You can create OpenAI account, create an API key, and then create a new credentials, and add those API key here. I'm already using the existing one. After adding the credentials, you need to select the model, which model you want to use. I'm going with GPT-4. Now let's add memory to this agent. You can use Postgres if you want to store chat history. And if you don't want to have a change in chat history, you can use Windows Buffer. Let's go with Windows Buffer. And let's add tool to this agent. Since we're building travel agent, let us add Google search sub API agent tool. Yeah. And for this, you can create a free sub API account. You will get 100 Google searches for free. You can use that API key here. I'm using the existing one. Yep, that's it. You have your travel agent. You can, for building this, you can just chat with it by clicking here. question, can you get right? Yep. So if you see, I asked you to get a flight from Delhi to Hyderabad on Jan 5th. It gave me three options. Okay. And here you can see how it's executing, which tool it is using. You can also check that each tool input and output. Yeah, you can also ask it to plan a trip. Yeah, you can play around with it and test with it. But yeah, you need to have an OpenAI account and a sub API to create this. You can use those links on the website to create those accounts. Yeah, if you have any questions, please let us know.
Yep. Thank you, Samanini. I think if you need any assistance in building this workflow, you can always take help from the our Asian University tutorial assistant that can give you that can provide you various steps on how to implement this. Any questions that anyone has so far? Please, we can have some discussion. We could attend some of your questions here. Vikrant, can you please zoom? Okay. How are these different from LangChain agents? So LangGraph agent is an extension of LangChain. So basically, LangGraph is basically you're grounding, you're creating a specific workflow and you're mapping that to a graph, and then you're doing that. If it is LangChain agents, it's the same thing. All LangGraph is actually built on LangChain agents. So there's not much different. Those are based on the existing LangChain's agent executor. LangChain has a module called agent executor, and all of this LangGraph is actually built on that, but by using graph CNN. So LangGraph is built on a graph convolution neural network, graph neural networks. It is using GNN, and that adds a lot of value to the complete architecture of LangGraph. It's pretty auditable, it's predictable as well, because if you're just calling an LLM, it can take any action. But if you define it as different nodes and edges within LangGraph, you are basically trying to define the structure of it, how it has to move to the next process. It has to go ahead, book a flight, then it has to go ahead and book for your hotels, not the other way around. So that structure you're defining here with LangGraph. Yeah, I think Hartik, I answered your question. Can you dismiss the note? Okay. Any other questions? Can we book hotels using this travel AI agent? Book hotels, not possible yet, but we can make it possible if needed through an hotel API. But always it has to have a human in the loop. We can't have agent go ahead and book a hotel because it can do a lot of mistakes. It has to take everything into consideration. But before it books, you can validate the plan and ask it to book. But at the moment, the agent that we built, it doesn't have that capability to just go and book the flight or book the hotel or even flight. It's just showing you, just planning it out. But if you give access to APIs to book a hotel, yeah, it can do that as well. Just about tool calling it. How this agents can deploy in customized app and any cost associated with this. Sangram, I just want to understand when you say can deploy in customized app and any cost associated with this, do you mean can this be incorporated to any mobile app or any kind of application? Can you please, repeat that question, Sangram, if you're there on the call? Or can you add more insights there so that I can answer that? Yeah, basically, Ankush, it's a good question. You said, how do these agents behave when recalling the stored chat? Do they still hallucinate or are they accurate with their recall? No, they are not 100% accurate with their recall. They might hallucinate sometimes. They might get recall information which might not be needed. So that is again RAG, how well it is doing RAG, because basically it is retrieving information from its previous conversations. So there is a chance it can hallucinate, but still, if you ground it, if you make sure that if you add proper metadata to all of the previous interactions, the hallucinations might reduce. But yeah, there's always a chance of these hallucinations within these systems. Always, it is advisable to create evaluations and benchmarking for this. We had a session last week. I don't know how many of you are in there. I do see some folks who joined the session after attending that session. So you always have to run your evals or create a benchmark to improve that accuracy, to improve the recall accuracy, the recall and precision accuracy. Which software are you using to build this? Yeah, it's LangGraph and Crew AI. See, the thing is, you could use these agents in a customized mobile app as well. The only problem with the agent is the UX, the user experience, right? When you have this agent, when you ask it to do some task, it might take a while to come back with a response. So that is where the UX might be compromised a bit. I mean, we are used to having instant responses because most of our applications are CRUD-based applications, but now these AI agents would require some time to do research, to go out and do some work. So yeah, you could still have apps do that. You can incorporate that in a mobile app, and the cost also depends on how many resources you're using, the cost on cloud, and also API token burning, how many tokens that you're burning, what model you're using. OpenAI model it can be costly. There are also cheaper open source models, but the reasoning power is not that huge. You can still reduce cost by using smaller models for smaller tasks, not offloading, not asking ChatGPT to give even complicated tasks. If there's a complicated question, maybe OpenAI API, ChatGPT, or maybe GPT models could take care of it. Huge models like Cloud or GPT could take care of it. Or if it is a simple question, maybe a smaller model could take care of it. That way, you're reducing the cost for it. Few cheaper options. What I would feel like is, you can use OpenAI API as your parent model. Build an agent, have OpenAI API generate lot of the tokens, lot of data that you can again use to train a smaller model. Now you can actually use a smaller model, train it and make it more efficient, make it as performant as OpenAI. So that is the best way to make it cheaper, but it does require a lot of engineering where you are creating different pipelines, a training pipeline. You are creating your benchmark, you're doing your evaluations, you're measuring the accuracy, you're defining those metrics, and then you're making it cheaper and cheaper. The other ways you can make the cost of OpenAI API go down is by using prompt caching, where you're caching some of your huge prompts, rather you're going back and forth to the same token. You're reducing some token cost by caching some prompts, some of the prompt. And the other option is also use other models as well. Like you have Llama 70 billion parameter model. Even that is better. It's good with certain benchmarks. So you can use a open source model. The cost would be cheaper. I think the recent model DeepSeek is only issue is it's a Chinese model. So trust is an issue, but still it is really good at generating a lot of tokens. It's way cheaper than GPT model, but it is equivalent to GPT 4.0 model. How can we create agents for particular domain or to solve coding specifically for technology-based domains as an AI agent? See, I mean, the end goal when you want to create an agent for a specific domain, you need to firstly build your AI agent. As I said, AI agent is only 20% of your work. You create this framework, you create these tools, you plumbing and everything. Then comes your evaluation, your validation and everything. So when you're doing this agent creation for a specific domain, you would also need a domain expert. Let's say you're going ahead and creating this agent for clinical diagnosis. Then even though you're a software engineer, you might not know if the agent is actually giving you the right response or not. But who would define that response and the quality of response? A clinician would probably do that. Maybe a doctor would able to understand that output. So a domain expert partnership is definitely needed when you're creating these agents. But if in case you want to trying to do the same thing, maybe you're a software developer and you're trying to build, you're building this coding agent, yeah, maybe you can evaluate it by yourself, right? But you at least need to know that coding language. If you're a Java developer, but you are building this coding agent to build something in Python, maybe, it can hallucinate, it can create vulnerabilities in code. So yeah, that could be an issue. Memory capacity for the agent. So memory capacity for the agent, you can use external memory, like you can use vector databases to store all of your memories and retrieve those memories. You could do that memory retrieval before answering a question or after it worked on a specific task, it can make use of that memory. So when memories are introduced, the output or the models might take some time to respond because it has to take into consideration of all of the previous memories as well to give you a specific response. So yeah, maybe there could be a bit of performance degradation, but yeah, still you would get it. Yeah, ChromaDB is a good choice. Yeah, you can use it. It's all vector DBs. There's a lot of vector DBs. ChromaDB, you have like, Quadrant or Milvus. Azure has its own vector DB, Azure Vector Store. Databricks has its vector store. Snowflake has its own Snowflake vector search. So every provider, there are a lot of open source options as well. PostgreSQL, Superbase has it. So PostgreSQL vector store is there. So yeah, a bunch of vector DBs that you can use to have this memory offloaded. How can we start? What technologies can we use for a POC for domain-based AI agent? So initially, you could stick to one framework. I don't know, Fayaz, what domain, are you a developer or if you're not a developer, then there's no-code solutions. But if you're a developer, you could use any of the frameworks which we discussed, LangGraph or Screw AI. But as I said, after you build that agent, you would probably need a lot of test data, a lot of evaluations that you would probably need. Yes. Any other questions? So Fayaz, so I mean, what is your domain, Fayaz? What are you trying to build your agent for? So let's say you want to build a agent for cloud engineering task, okay? I'm just assuming you want to build a cloud engineering agent, okay? So your cloud engineering agent is supposed to go and get you details about your cloud budgeting, or maybe it has to go ahead and do some auditing about your cloud environment. So the test data is what are the usual tasks a cloud engineering would do? You are basically asking OpenAI or these models to create synthetic data. So what would be a regular cloud engineering task? It could be go out and check if there are EC2s running, go out and do a call to a billing API to get all of the billing that is consumed by compute or maybe by storage in S3, or maybe you're going ahead and getting some information regarding some databases, or maybe provision IOPS, or maybe you're consuming more billing on the networking side. So you're basically comprehending all this information and then you're doing that analysis. So you can create a basic agent and give it this task to see if it is able to go ahead and get that information. Is it able to go ahead and make API calls to AWS and get the data and then comprehend what is it. I mean, we built something similar actually. There is an agent that we built which actually does similar to cloud engineering task. Guys, I mean, anyone aware of that? I think it was so this is one of the agents that we are building. We're working on it. Oh, so okay, yeah, I think it's probably
Mm, do you
yeah.
want me, do you want
Yeah.
me to start the service?
Yes, can you start this? Yeah. Yeah, this is a basic cloud agent that we have built where you can ask it questions around billing and everything, Fayaz. It's a patient analytics for a child clinic. Okay, if it's a patient analytics, probably it is something related to patient data. As I said, you need a domain expert because if you are going ahead and building something for the patient, you need all of the information about. If it is just analytics, are you just targeting like how many patients coming and go, just analytic workload, then you may not need an agent, right, for analytics. But if you're creating anything like something more in the clinical practice, or maybe something related to some questions around around healthcare, then probably you need a domain expert because you can't trust these models output. Yes, Jack, I think you can implement an error correction. So Lens, whenever there is an API that fails, it can give you the information that, hey, there's something happened with this. So you can give this agent access to your service itself. Let's say there's an API call and now your logs might be throwing an error saying that, oh, SERP API is out of limits. We ran out of limits in SERP API. Then it can understand it. How it can understand it? You have to give it access, a read-only access to your service logs. Then it will understand what is the issue. And then it would tell you, hey, there is an issue with your SERP API. It got exhausted. And this is what you could do to recover that. Or you could have agent only recover, which we don't recommend. It's not even recommended for to give your agent access to its shell where it is running, because you can't trust these models. Recently there was also research where these models are self-replicating themselves. So like a virus, they are creating replicas of themselves. Anything could go wrong. I mean, you can still create some guardrails on it. Like even if you want it to execute some command to recover an API, you could give that information to it. You can tell, hey, this is a tool. If you want to recover, this is the command you need to execute. And this is the tool call that you need to do. Maybe it's a kubectl command it runs, or maybe it is some other command that you will run to go ahead and restart the service, but you need access to that environment, right? So executing it might be a problem, but at least to get the logs and do some analysis, you can do mainly by giving it a read-only access. If it can tell us the issue and you could go ahead and act on it, or you can just say, okay, just go take the action. It will just go and do a function call and will take the action. But human in the loop is definitely needed here. It should not be autonomously taking that API call fails. It should not directly handle it. It could handle it, but giving access to its own environment is risky. Is it possible to optimize the way OpenAI processes the tokens once a request is sent from an agent? I did not get this, Ankish. You're saying, to save cost, I'm trying to build an agent for mental health screening platform. Is it possible to optimize the way OpenAI processes the tokens once a request is sent from? Okay, it is possible to optimize it, but what kind of optimization are you talking about? Is it to save cost? Then yeah, you could optimize it, but when already the tokens are generated, um, uh, I'm not able to understand this 100% your question. So is it to save costs? What kind of optimization? Because the way OpenAI process the tokens is up to them. We can't regulate anything there on how it is processing the tokens. Only thing that we can use to save cost is something called prompt caching. You guys, you can actually research. It's called prompt caching. If in case you have a huge prompt, maybe since it is mental health screening, right? So mental health usually is screened with something called DSM-5. So DSM-5 is like a Bible for all of the psychiatrists who are treating mental diseases, right? Depression and everything. So this is a huge PDF file. So if you want to make any kind of suggestions to a patient, that has to be in that book. So what you can do is you can actually cache that entire book as part of prompt caching, put it in there with the OpenAI, because now you don't have to send huge chunks of data back and forth. Rather, this entire thing will reside with OpenAI, and any of the suggestions that are given from OpenAI would be through that book itself that is defining that DSM-5. But you don't have to do a lot of back and forth of pass of tokens, because now there'll be a huge chunk of tokens that will be processing, right? Because OpenAI charges you based on every token. Here you're saving cost significantly, and you're also improving the response time, because you're not having a lot of back and forth of these tokens. Okay, I think we have done something similar actually. We're on mental health screening. So we did the similar approach by using DSM-5 book. I'm new to AI, but have knowledge in machine learning. What is the path should I follow, and technology should I learn to build models like this travel AI agent? So machine learning is, since you already have experience with machine learning, I think if you want to build an agent like travel agent, it's basically you could do it programmatically, but still there's a lot of evaluation and benchmarking that you would probably need, Sri Krishnan. So you have to create a separate data set, maybe a test data set that is used to refine the prompt on how you can improve the agent performance and everything. So you can learn this. I don't know how much coding knowledge you have, but if you have Python knowledge, you can create agents like these by using Python. So Fayaz, we are going to make this cloud agent open source pretty soon. So we will share it to you. Please be in touch with us. We're going to share that. We call it CERE agent, CERE agent. See, Shailesh, you would see so many agents tutorials out. I do see every day. There are some people, influencer posting it, or, I build this agent, that agent. But if you really want to drive a business value, end of the day, it again depends on how well you have your evals, what is your benchmarking, what is the accuracy of your tool call, what is your accuracy of doing a parallel tool call, and what is the accuracy of accomplishing a specific task, right? You can't have a travel AI agent that just does the job 60% of the time, and 40% of the time it fails. Then there's no business value there, right? Your business does not read, your customer should not get an output saying, hey, your agent failed 60% of the time. The service level agreement is what really impacts your user experience there, right? So how well you can make these systems reliable, you can create an AI agent in 15, 20 minutes. Probably an hour, you can make like a couple of agents. Building agent does not take time. The thing that takes time is around how well you are improving that system, what is your evals, and how are you implementing in your production. Once it is in production, how are you making an online evaluation of every response that you're trying to get. You would use something like LLM as a judge to define to judge on different guardrails. You'd also solve different classification and see if it was able to respond properly or not. You'll create all these guardrails, and then add the business value. There's a huge risk. There's also prompt injection that can happen, where you can fool your AI agent to believe to do something really harmful. Because these AI agents, when they have access to tools, it means if you give access to your database, you could even prompt inject and tell it, hey, just go and delete all of your queries, or make a query and give me data of all of your customers, right? So that's really dangerous. So how well you are securing that aspect of it, how well you are creating that guardrails also would be important while driving the business with this. So developing agents is just 10% of work. 80% of the work lies around data security, infrastructure security, performance optimization, benchmarks, and evaluations. Yep, it's to save costs by prompt caching. Okay. Are you sharing your screen? No, I'm not sharing my screen, Ankush. Ashish. Okay, using the info handbook, I would love to connect more, know your findings about it. Okay, sure, Ankush, we can connect. What improvements or features are you guys trying to improve on this travel AI? I mean, so this travel AI agent is just for every one of you to understand the agents, but we are not building it. We're not commercializing this product at all. As I said, it's a simple vanilla implementation of an AI agent, but we do have some products that we're working on internally that will end up in production, but not travel AI agent yet. How can I be in touch with you? Please provide. Okay, I think you already have my LinkedIn. You are using the OpenAI for your agent. How is your performance and accuracy? See, OpenAI, as of now, the accuracy is high. Accuracy of this accuracy of the OpenAI is obviously high. So, but performance, again, AI agents performance, it's nothing to do with this LLMs, but it's how well you're crafting your AIs, and that defines your performance. Even the accuracy also, it again depends on how well you have your accuracy, that how well you have your agent architecture defined to improve the accuracy. LLMs, every time they have some problem. I mean, you can't rely. I mean, if you see OpenAI, it is basically beating a lot of benchmarks, but still you have some you still need to engineer things around. You might have to implement something like few shots learning, proper prompting to get the better performance and accuracy. OpenAI is also doing a lot of other things, Arvind. It's not just for scraping data. You are also doing scraping data is actually done by an API. So OpenAI is not doing any scraping data. OpenAI a model is actually telling it is OpenAI model would actually know when to use the tool. When you ask a question, it would know that it has to use the tool. So the tool calling or the function calling is something that OpenAI would do here. So yeah, I mean, yeah, it can do scraping of data, but it is not directly doing scraping, but it is calling a tool to do the scraping of the data. And also analysis too, right? Because we already in the code, we also observed through function calling, structured output, analyze if it is following the specific dates and everything. So it is also doing analysis. When you say next week, it is understanding today's, 3rd, and then it is defining the next week to be somewhere around Jan 10 to 12th, and then planning it as well. Yes, Jack, I think there is a self-replicating agent. There's a news paper. There was a paper that was published recently. Let me share you that paper. I think this is I'm sharing you that paper here. If anyone who wants to read this paper, please go ahead and read it. So it's basically around self-replicating. This team, it's a Chinese research group who have worked on this. They did some testing and they found out that some of these OpenAI models and others have ability to self-replicate given the environment. So you give it access to an environment, there are ways where it can self-replicate itself like a virus, which is really dangerous. And by giving it access to a shell is how they are accomplishing it. So we should, just like when you give elevated access to a process on your machine, on your Linux machine, it's not good. Same thing with AI agents. You should never give it elevated access to your shell. Otherwise, it might hack its own environment, or it might just escape as well. There's a new research that came out where AI was trying to escape and create itself in other areas by hacking other systems. Data protection, absolutely. Data protection is definitely needed whenever these agents have access to any data sources. We should always make sure that it doesn't have access to any PII. Most of the details should be masked if in case you're dealing with any customer data. And a lot of the integrations inherently provide a lot of data protection as well. And whenever you rely on these models to generate queries, that is also not a good practice. You can't have your LLM say generate queries on the fly. And get data because it can hallucinate or it can generate query which could be harmful. So it's always better that agent can only read data but not execute anything on the databases. So that way you can ensure that the data protection is definitely taken care of. So yeah, I think it would be a really important. Data protection is always important, and whichever environment, wherever you're working, so data at rest, data in transit should be secured. As AI agents, you can't trust those systems; they are undeterministic. So yeah, it's not always recommended. And yeah, thank you, Verma. So we do have other new events coming next week. Please do follow, share on LinkedIn. Please share about Asian University on LinkedIn. If you can have any screenshots taken, please promote us on LinkedIn if you really loved our session. And we will conduct. We have 4 events this month. 3 more events coming up every week this month, and then next month we again have other events where we'll be focusing more on the production level design of these AI agents. We're not just focusing on just toy examples anymore. We'll be also moving into how to design your memory, how to create memory backend systems, memory backend design for these systems so that you can move into production as well. If any one of you are interested in, please like our LinkedIn page as well. We are still making this Asian University platform. We're maturing it a bit more, and so that everyone would have access to our platform who can not just learn AI agents, but also build your own products on our platform. So that is the end goal for us. So we'll be working on that and have that released soon, where you can actually not just learn AI agents, but also you can build and productionize your own agents and build your startup as well. So that is a plan. Sorry, probably by mid-February, you would probably see those features, a lot of those features rolling out slowly every week.